All right. Well, I'll go ahead and get started. I'm a little bit nervous this morning, a little bit, or this afternoon. More so than normal because I'm actually going to start out with a confession. Don't worry, it doesn't involve viruses or anything like that. But it's actually that I'm not going to actually talk about what I told you all that I was going to talk about. I'm going to talk about something else. I do think that it's important. I think that and in the last couple months and the stuff that I've been working on, I think that it actually has a greater potential to be more useful to you and make your life easier, which is what I sincerely hope. So what I'm actually going to talk to you about is command line interfaces, which you're thinking, oh my goodness, why are you going to talk about command line interfaces? All the great things you could talk about. But as a developer, the primary way in which you experience your world is through streams of text. And so I think that we can do a lot better than what we're doing right now. So yes, I am in fact going to talk about CLI. And to drive the point home, why it's worth it.
This could be a lot more complex. I mean,
can you guys hear this?
It might not be just such a simple, you know?
What in God's holy name are you blathering about?
Well, I'll tell you what I'm blathering about. I've got information, man. New shit has come to light.
So as a company that focuses on crafting human experiences, the developer experience is something that's very, very important to us. And it's why we take CLI tools very, very seriously and why we end up writing quite a few of them. And there's the space is very crowded for option parsing tools. Slop, Trollop, Mixlib, Map, Optitron, Rake, Thor, GLI, option parser. It's just fun to say them all. And there's probably 20 that I haven't even mentioned here. And each one of these is written by people who have very strong opinions about problems that they need solved for them. And each one of these, I can honestly say, have given me, I've used a lot of them over the past 5 or 6 years, and they've all given me this great feeling of win where everything is going right and you know, nothing's going wrong for you. Which I never get tired of watching that. That's the feeling we're going for all the time. That's what you want. But unfortunately, when it comes to writing command line applications, inevitably, I end up feeling like this. I hit a wall. And I won't play the sound for this one. But you end up getting, you end up hitting a wall at some point, or at least I do. And so I'm going to talk to you about what that is, what happens. Oops. What happens to make the experience difficult for us? So the first thing is output. Now this is probably the biggest bugbear of CLI development, at least for me. The one that causes the most irrational fear and loathing is the way that we manage output to the terminal. And the basic problem, as I've identified it, is everybody just writes straight to standard out. Everywhere in code, this is something you see a lot. And sometimes this is appropriate for small systems, but as your system grows, you have more and more code that's contending for this single resource, and it's a global variable, and it sucks for all the reasons that singletons and global variables are no good. You see this a lot. These are just all other realizations of the same basic anti-pattern. So how do you share calls to puts? And by puts, I mean, you know, standard out. And the thing is, you don't. There's really, there's a dearth of techniques as your program goes to manage it. People need to generate output, but the question is how. The next thing is, how do I actually share formatting code in a command line application? And this problem is when you have a bunch of actions that are generating output, and they share common attributes. And so you really want to just substitute the things that vary, but other things stay static in that context. So an example is, this is from a command line interface we actually wrote with Thor a few years ago, is the help. We wanted, for historical reasons, we wanted to tweak the way that help looked in this command line interface. So what we ended up having to do was write this class, which is a method that makes imperative calls to standard out and does kind of formatting by Ruby code. And it's not important to understand what exactly is happening here, other than it's incomprehensible. Or it's very difficult to see what's going on. Basically what I want is I want to print out the usage and the help options, whatever those are. But I'm printing those out, printing out a new line, and then delegating to some other method which has the side effect of printing the standard out. And there wasn't really a clear way to go forward on this, or to get it any cleaner than this. The other problem is it's very difficult to embed other streams into your output. So at some point, your command line application is going to want to call out to some other application, or many applications, and it's going to need to integrate its output into, or you're going to want to integrate its output into your own output. And you see, this with like an indentation prefix. So like Heroku build packs are a good example of this. They actually have very strict style guides inside the build pack of how many levels of indent and how many arrows you should use and stuff like that. But I would argue that that's not the concern of the build pack. It should be the concern of the thing that's rendering its output. The same thing with control characters for when you're integrating external streams. If those contain control characters, what do you do with those? It can run into headaches. So an example from this, I tried to pick one that was would be maybe not, familiar to everybody, is like Capistrano, which is actually a great program. I like it a lot. But Chef is guilty of this, and everybody else. But here you can see the output of bundler gets 1 dot per line, and then it's just inserting random new lines and putting. It's the IP address of the server that's running is relevant information, but I think that the reason it's like this is because doing any different was really, really difficult. It makes, I should be, if I'm familiar with the output of bundler, I should be able to look at this output and immediately recognize where bundler's output is, instead of having it broken up like this. The other thing is when you want to do things like progress bars. I love the Ruby gems interface. When you install a gem, as it's fetching, it shows you its progress. And this is a basic UI principle that if you're going to block for more than 600 milliseconds, you really ought to be providing some sort of feedback to the user so that they know that you're still doing something, and that, most of all, that they're in control of their workspace. You haven't taken the control out of their hands. But doing so is actually pretty difficult because you have the progress bar is going to be writing to your standard out separately. In fact, if you look at if any of you guys have used the Formatador gem, you call out to it and it writes to standard out directly. It uses a constant by name. So the other problem that I constantly run into, or we constantly fall afoul of, is decoding and validation. And what I mean by this is that our inputs are strings. Our arguments are strings. Our option names are strings. Our option values are strings. But we don't want strings. That's great. Strings are the universal interface, and they're good to have, but we want not strings, but entities about which we can know facts in which we can derive values. We want knowledge that's encoded in those entities. We want objects. And the sooner we can get from strings to objects, the better off we're going to be. And this is a problem as you find strings getting very, very far into your program, and they're just difficult to work with because there's nothing encoded in them other than that one byte comes before the other. And so we want to front load the extraction of that information. Or I constantly have a problem with this. So for example, what I mean by this is I've got this string, and it's just a string, but what I really want is a path name object that represents the fact that this is a path. This is, in essence, the concept of decoding, and the decoder that I want is the global path name function. The same thing for this. This is an IP address. This is a string, but what I really want is an IP adder object, and the decoder for that is just the constructor. To do another case, we might have my email address, right? But what do I really want? I don't want my email address, even if it's a primary key that uniquely identifies me in the system. What I really might want is an active record. And so the decoder for that would be defined by email. And I would argue that before you even start to take any action that depends on having the user, you should decode it and not be invoking that by hand. So anyhow, it's not enough just to have decoded objects. They have to be valid. This is why I talked about decoding and validation. Decoding is an existential problem. Like, can I actually get this thing into a representation memory that I can use? But then once you've answered that question, yes or no, then you need to say, can I even use this? Does it make sense to use that? And that's what validity is. And I think that it's important to acknowledge that these are separate concerns, that decoding and validation are completely and totally separate concerns. But I think that they often get conflated because they both need to happen successfully in sequence before you can continue. So just to drive this home, you've got, I don't know how many people are familiar with this, but in 57, Noam Chomsky, proposed this idea, or basically proposed this same idea as applied to English. Here's an English sentence. It parses perfectly correctly, and yet it completely and totally evades understanding. So in this one, you have a well-formed sentence. It decodes properly, but it's invalid. It doesn't make any sense. We can't gain any knowledge from it. Can't use it. So the same applies to objects and in different contexts. So to use the path name, once we've got this well-formed path name object, the questions we then want to ask is, does this exist on disk? Or, do I have permissions to write to it? Which I may or may not, depending on the context. So I feel as though this is not just a problem with command line applications. I feel that the Ruby ecosystem, and perhaps in general, has a bias towards output instead of input. I mean, you think about all these tools. How many templating engines are there? We've got decorators and presenters and renderers and all this stuff for laying things out and generating great input. But when it comes to actually very orderly, repeatable ways for converting strings back into objects, it's hard to find. But I think that it's very important, because the sooner you can get to that level of knowledge about the data that you're working with, your programs can be so much smarter. Because strings are great, but strings are dumb. Objects are smart, and smart programs will have use smart objects. The other thing that inevitably happens is as you develop a command line application, you're going to need a plugin system. And that's because at a certain point, when a program grows in complexity, You just have to, it must be broken down and distributed into smaller pieces. I didn't write the rule, but I can assure you that that is fundamentally what we do. And the same applies for a command line application. And so, I mean, as your CLI grows and subsumes more and more responsibilities, it makes sense that you need to break it down into component parts. I mean, you think of CLIs that we use every day, like Ruby Gems, Vagrant, Heroku. All these do a great job, actually, of making it very easy to extend, and they reap great benefit from it. I mean, it's self-evident when you look at those things that that was the right thing for them to do, and that if you are going to follow in the footsteps with a similar thing, that you're going to have to do it. And I think that that's, again, true of any software that you're writing. So I've just, Rails engines, Jenkins plugins, TextMate bundles, to name a few. I mean, almost you can kind of name an ecosystem, and they've got a plugin system and extension system. So I need plugins. What am I going to do? Well, this is the part where every single time I look at it and am I going to have to implement that? It's not that it's hard or that it's unknown, or even that you can get most of it by leveraging Ruby gems. It's just one of those tasks where you know you're going to have to do it. And the path to do it is clear. It's just long and arduous. And to me, that shouts, you should get that for free. Like, you should be using a system where you get that for free. And that's why there's such a proliferation of plugin stuff. So I could go on and on. There's a lot of little paper cuts that I had to cut out of this talk that I think are wrong. So I picked kind of the most the biggest issues that I have, and so I need to actually pivot a little bit and start talking about solutions. Otherwise, what's the point? But I will leave you with this: a option parsing DSL is not the same as an application framework. I know it's important to, I know it seems obvious, or it may seem obvious, but this is something that you need to bear in mind when you're evaluating option parsing libraries and things that map arguments to classes and objects. I'd even go so far as to say that this is a completely and totally solved problem. The problem with command line applications is not the conversion of strings into hashes. It's literally everything else that I just described, because ultimately you're developing an application, and that's only one part of it. So we'll fast forward or rewind something 6 weeks ago, a couple months, 2 months ago. Like, this is after I'd already submitted my talk. We were hired to write a command line tool for Rackspace to make their technology more accessible to developers. So we're talking about a CLI that's going to potentially interact with arbitrary bits of their technology, and it's going to have a lot of commands. It's going to have a lot of library code. It's going to have a lot going on. And so everything that I mentioned plus more is definitely in effect. It's going to have to, like I said, have a very large surface area, the things that it could cover, potentially infinite, right? So absolutely plugins are something that are going to be required. So what are we going to do? Well, we have to identify these problems and go after them and see what we can do to address each one specifically. So the first thing for output, contextualize the streams. I know that's a fancy way of saying wrapping stuff, and what I mean by is we wanted to move away from this regimen where any code anywhere can just access standard out willy-nilly. But at the same time, we want any code anywhere to be able to generate output. And so how do you do that in an orderly fashion? It's not an easy problem. One of the things we actually found was the introduction of middleware, which I'll just give a quick review of middleware, because I mean, why would you want middleware in your command line application? So yes. Middleware is just a pattern where you have an application that's comprised of little bits that share a uniform interface where that basically yields control one down the other through the chain. If you've used Rails, probably everybody's familiar with what middleware is. The question is why is this appropriate for a command line interface? But first, we kind of want to look. First, let's look at what does middleware in a CLI context look like. Well, the first thing is you've got to capture the essence of what the Unix process model is, or what a command is. And it's actually quite simple. I might be missing something here, but you've got a list of arguments, an input stream, an output stream, a stream to log stuff to, and a hash of environment variables. And really, it's just a data object that can be passed from one middleware to the other. And then the actual middleware API is very simple, right? It's just a simple instance of the middleware pattern. You've got a call method that takes the command. You can do stuff beforehand. You can yield control to the middleware downstream and then do stuff afterwards. Nothing new there. But it's important to remember that each middleware controls all of the streams and of the downstream middlewares. I know that's kind of a mouthful, the downstream streams. But it can wrap and present those streams in an orderly fashion. So here's an example, just to kind of put a concrete point on it. Let's suppose we had some emoji middleware that just wanted to take, that just took all of the downstream output and substituted the emoji characters for their equivalents on the terminal. This is basically all you would do. You would wrap the command that you got in with exactly the same things, but you notice that the output now has this filter on it. So every middleware downstream has no idea that there's this filter on top of it. It can just generate the output and doesn't have to worry about it. And we can just assume that everything will go through this. But that's only one piece. I think the biggest piece is using templates. I know that's shocking because templates, but I can tell you, templates are not just a tech fad. There actually is real, there's real value in templates. I know that might be a shocking proposition, but templates are actually, when it comes to laying out text, templates are kind of where it's at. You can do things like achieve layouts by wrapping, by using layouts and partials like we do in Rails. So to revisit this help example that I had here, we've got a layout that's an imperative Ruby code, and the same thing implemented as a template. And I'll let you decide which is clearer, which intent is clearer. The other thing with the RUM tool is we wanted to make sure from a very get-go that the templates were streaming. So what that means is as the templates are incrementally evaluated, those bytes are actually finding their way all the way through the middleware stack out to standard out. So as you're evaluating the template, it's actually going to standard out. That needle is being threaded, but all that happens without you seeing it. So you're just thinking that you're in a template, and that allows you to further narrow the scope so that the pieces that are generating the output can just still generate the output as though they're rendering to a stream, but the fact that that rendering happens in the context of a streaming template is something that's hidden from them. And one of the things that this enables is you can have streaming components. By passing control of the stream to something that's embedded in the template, you can pass control to a streaming component and then back. And so an example of this is doing a progress bar inside of a template. This should totally, there's no reason I shouldn't be able to do this. The only, to say, okay, I want to substitute the gem name here and then the actual progress, and have that, because I've evaluated the first part of the template, that gets written to standard out, and then the control passes to this progress bar. It can then render to standard out, but then I pick right back up where I was formatting, and so I've very cleanly captured the overall layout, which is what my goal was in the first place, and I can say layout this, and the progress bar goes here. So templates are awesome. They're like a thing. It's very surprising that we don't use them in CLIs very much. So on the decoding and validation front, we actually ended up. This was a toughie to kind of figure out what to go with, but the answer ended up being introduce a new object. Go figure. So what we did was we introduced the concept of forms, which in a command line application, forms, it's kind of strange, but there's a subtle choice of language here, and we actually struggled with this, but we ended up going with forms in the Platonic sense of the ideal shape of something, or its projection in the highly etheric world, if you're into the whole Neil Stephenson thing. So we're talking about what is the essence of your input for this action. And so to just to put some concreteness on that example there, here's the input form for the create action, the load balancer create action inside the rum gem. And you can see we're just listing out the inputs. We're listing out the types, any defaults, how they're decoded, which is just you can just use a proc as a decoder. There's also a couple of other ways to decode, and then we're validating by just giving it a field name and a predicate, So we've very cleanly captured what is the form of the input and what is the validity of it. And so you actually have one of these forms for every single action. And so once you have this, then you can actually derive your option parser. You could really use any option parser you want. You can use trollop or slop or opt parser or whatever, because at this point, this is what's primary, what's antecedent. But let's take a step back and think about this for a second. We've got templating system, validations, middlewares, all kind of happening over this rack-like API of a middleware dispatch chain. And I mean, I don't know if anybody here is like thinking what I'm thinking, but you know, are we going down a well-trodden path here? Are we actually reinventing Rails? Yeah, kind of, yeah. But that's okay. I think that's just fine, because there actually is a very deep correlation between command line invocations and web requests. And you know, part of that is that web requests actually have their has its roots in the Unix process model via CGI scripts. But you know, you see like a command line has standard in kind of maps to request.body. It's an input stream. It's got an output stream too. It's got a list of arguments and parameters and options, and it's got this integer that represents kind of at the very most coarse level what happened. And then you've got kind of general metadata that you can associate with it. So it's actually not surprising that these patterns that are applicable to Rails are almost directly one-to-one able to port to the command line interface, because there's a lot of similar concerns. So I have I don't know if you're familiar with the concept of convergent evolution, but here you have a dolphin and a shark, which both share very, 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 very little by way of heritage. But at the same time, they share physical characteristics that are very similar. And that's because they're both ocean-dwelling fish eaters. And so it just is a simple fact that if you're an ocean-dwelling fish eater, it's good for you to be able to swim quickly. And so you'll develop a tail with a fluke. Now the shark's is up and down, and the dolphin's is side to side, but it's the same basic mechanism. And it's because of the habitat that they and niche that they occupy. So let's see how far we can take this. Once we kind of made this realization, we're like, okay, let's roll with this. Let's just crib and cargo cult everything we can. And so here's actually a snippet from the RUM routing file, and you can see, you can match arbitrary strings to controller actions, and you have similar resourceful routing. And so this snippet here, there's 50 commands embedded in this. But the intent is actually you don't get lost in the noise. I can really see what this is about. And that's very powerful. There's a reason it's powerful in Rails, and I think it actually works very well for the CLI. So we actually have extracted this framework. It's currently on my GitHub account, and we call it MVCLI. And all of these patterns are there available for you to use on the command line interface. The RUM tool is built with it. It's going to continue to be developed. We're actually in the process of developing this plugin architecture. So if you are going to develop a command line interface, you'll actually be able to you'll get all this stuff basically for free. Because command line applications should be applications. They're not scripts anymore. And it is nice. It is nice to know that these things have your back. Rails is valuable for a reason. Even these frameworks that we have, they're valuable for a reason. And so I think the most important thing to realize is that a command isn't an object. It's not a class. It's a process that unfurls according to the rules of your business, whatever that is. And I, for one, am going to start treating it that way. So that's it.